Hi everyone, this video is to go over 2-16, multiplying and dividing rational fractions. The first page is a page that we intend to do together, but if you are absent or you are working from home on the day that we are doing this, please make sure that you will continue to watch this video. First thing I'll do is grab a text box to be able to type my name and the date. So this top part is basically some rules and the notes that we need to remember in order to be able to multiply and divide with positive and negative fractions. This first box in the upper left-hand corner says when multiplying or dividing any two terms, same signs, the answer will be positive. Remember, we learned that when talking about integers, this will not change now that we're talking about fractions. And then different signs, the answer will be negative. What this means is if you multiply two positive numbers, you get a positive answer. If you multiply two negative numbers, you get a positive answer. If you multiply a positive with a negative, you get a negative answer. Those exact same rules apply for dividing. To remember this, we used our faces, so I'll draw a couple of faces. Here, these two boxes are same signs. So I will put first the positive signs. The eyes are both open. This is a happy guy. He is smiling. That smile is associated with positive. If he has both eyes closed, he gets to nap for a little while or sleep in. So he is also happy, and we associate happy with positive. Different signs, though, when we put a positive and a negative together, it looks like he's kind of got a black eye. So he's not happy about that, and he's frowning, which goes along with negativity. It doesn't matter which eye. It doesn't matter which eye is the black eye, so we'll put that for both. If he has a black eye, he's not happy. So this space down here is for examples, but since you are watching the video, we're going to skip the examples and just do the examples at the bottom. Here's a side note. A fraction will be negative as long as there's only one negative sign. It doesn't matter where the negative sign is. Here, for example, it says negative 4/5 is equal to negative 4 over 5, and that's also equal to 4 over negative 5. Along the right, it says to try it. So the first one says negative 1 over 2. We could write that as a negative fraction, negative 1/2. We could also write that as 1 over negative 2. As long as there is one negative in that fraction, it is a negative fraction. You'll need to know that in order to be able to apply the rule of same signs or different signs. Here's another example. Negative 7/12 is the same as negative 7 over 12. And that is also the same as 7 over negative 12. All of these are negative. The same thing would apply to the bottom one, but to keep our video shorter so that I can keep you engaged, I will skip that bottom one. So here are some reminders, and you're going to need to fill this in on your Cami doc. So everything that I fill in, you'll need to fill in. So this video might require you to listen, see, pause, and then go do the exact same thing on your own Cami doc so that when you turn this in, the entire page is complete. The entire first page should be done with as much as I do with you. So here in this top section for multiplying and dividing, it says reminders. When multiplying with fractions and whole numbers, we need to give whole numbers a denominator of 1. In order to be able to multiply the denominators, you need to have a denominator, and that denominator for a whole number is 1. You would turn mixed numbers into improper fractions. Boxes are a little bit small here, but that's okay, as long as you've got these notes to be able to use them for the rest of the page. And then if you get an improper solution, so if the answer turns out to be an improper fraction, you would want to go back and put that in as a mixed number. Improper fractions aren't necessarily wrong. They're just not typically how we would leave the answer, at least not in this at this age. So here, multiplying fractions, it says, remember, multiply, multiply, simplify. Those are the 3 steps. Multiply, multiply, simplify. First, multiply means multiply the numerators together. So top times top. The next multiply means multiply the denominators together. So that would be bottom times bottom. And then for that last step, you just simplify as if possible. Now remember, you can also cross cancel prior to solving. Sometimes that makes it a little bit easier to simplify the fraction if you do it before you multiply. With division, we basically just don't divide fractions. So back in 5th grade, you learned that instead of dividing by a fraction, you actually multiply by the reciprocal. You might not remember what those words mean, but you might remember the saying, you just keep it, change it, flip it. What that means is if you are given any problem that has a fraction in division, you keep the first number the same, you change the multiplication to division, and you flip the second number to its reciprocal. A reciprocal is just taking that number and flipping it upside down. So the reciprocal, I'll do a couple of examples. If we have, for the second number, if we have 2/3, its reciprocal flipped upside down would be 3/2. If we have -5, its reciprocal, well, we would need to flip it upside down. So before I flip it, I want to give this a denominator. Remember, a whole number is the same as a fraction over 1. So if this is -5 over 1 is the same thing. Its reciprocal flipped upside down would be -1/5. The sign will stay the same. The number itself is what gets flipped. So we're going to look at some examples before you do the second page. There are 10 problems on the second page for you to do. We'll do some examples here together. Just so you know, and I don't forget to tell you, at the very bottom of the Cami doc is a plus sign that I'm circling with the mouse right now. If you need additional workspace or if you want more scrap paper, all you have to do is click the plus sign to add more pages, and you can choose whether you want that to be blank, lined paper, grid paper, whatever you need in order to do the problems with neatly and showing your work. So here we have 4/9 times -7/4. I prefer to cross cancel, and what that means is you look at the crosses. So I'm going to try and use a highlighter. Not sure if that's going to work. The numbers going across from each other are the crosses, and my highlighter does not seem to be working, and I don't think it will work on an angle. No, it will not. It will just make one big box. I don't want to circle this with the marker because that just makes too much stuff on the page and it gets all messy. But the numbers going across diagonally from each other, if they share a common factor, you can divide both of those numbers by the common factor to reduce before multiplication. So here I see 4 and 4, and this is a gem. Whenever the numerator and the denominator that are opposite of each other are the same number, that is the greatest common factor. 4 goes into 4, so we could divide them both by 4, and what we get is 1. 7 and 9, you don't have to worry about the negative. You'll just deal with that negative during the multiplication. 7 and 9 do not share a common factor, so we cannot cross cancel. Now, remember to multiply fractions. It says here for the second box down, multiply, multiply, simplify. So that's multiply the numerators, multiply the denominators, simplify. So looking across, I've got 1 times -7. I know that that is -7, and 9 times 1 for the denominators. So we have here a total of -7/9. For the second example, we have -2 times 3/7. I'll first write this whole number as a fraction, which is -2 over 1. I cannot cross cancel because the diagonals do not share common factors, so I just multiply across. Numerator times numerator, denominator times denominator. -2 times 3 is -6. And 1 times 7 is 7. Remember, the asterisk means multiply. I'll just double check to make sure that I can't simplify, and I cannot because neither 6 nor 7 share a factor other than 1, and dividing by 1 would not help us. For the next example, we have a mixed number. Remember here it says turn mixed numbers into improper fractions. Remember, to turn a mixed number into an improper fraction, we do what is called make it mad. We're going to make it mad. We start here at the 5 and we multiply, add, denominator doesn't change. So I make a C, I show that I start at the denominator 5, I go around this mixed number in a fraction as a C and make it mad. Multiply, add, denominator doesn't change. So that this would be 5 times 1 is 5. Plus 3 is 8, all Okay, I may be repeating myself, but my recording was interrupted, so I'm just going to go back to my train of thought. Here we have 5 times 1 is 5, plus 3 is 8. So that's our new numerator. Denominator does not change, and the sign also will not change. So I'll bring that negative down. We are multiplying that by negative 2/5. So now I can see that I cannot cross cancel anything. I cannot reduce the fractions themselves. I have a negative times a negative, so I know that this is going to be positive, and I just multiply across. 8 times 2 is 16. 5 times 5 is 25, so my answer here is 16/25. I am going to rewrite this answer right at the end of the equal sign, just so when grading, it is very clear what the actual answer is. The next example, negative 3/2 divided by negative 10/7. Here, down at the bottom on the page, you've got all the notes that you need now. It says we really don't divide. We multiply by the reciprocal. So think keep it, change it, flip it. We keep the first number the same, so negative 3/2 will not change. Halves. Change the multiplication to division, so I'm going to change the sign, and then it says flip the second number to its reciprocal. The negative won't change. 10/7, though, will be flipped upside down, and it will become 7/10. I'm looking at cross-canceling, and I see that 3 and 10, the only factor is 1. 2 and 7, the only factor is 1. So we cannot reduce this in the problem. And I will just multiply across, but I'm going to pay attention to the signs. I've got a negative times a negative. The answer is going to be a positive. 3 times 7 is 21. And 2 times 10 is 20. Here we ended up with an improper fraction. It's not wrong, but it is requested that you change this back to a mixed number. In order to do that, you have to ask yourself, how many times does 20 go into 21? I know that it goes one whole time. That means that I just used up 20 20ths. So I'm going to have to subtract 20 20ths, because 1 times 20 is 20. I used up 20 20ths from the original 21 20ths that I had to start. So 21 minus 20 is 1, and the denominator does not change. So I'll put my answer 1 and 1/20th up here in that space so that I can check it easier. And then the last example here, we have negative 5/8 divided by 3/4. I'm just going to draw a little box around here so none of this gets mixed in with this answer. So we've got division with fractions. We don't do that. We'll do keep it, change it, flip it. So I'm going to keep negative 5/8 the same. I'm going to change the division to multiplication, and then I'm going to flip 3/4, so it'll become 4/3. Now this one I see that we can cross cancel, because looking at 4 and 8, I know the greatest common factor, the biggest number that goes into both is 4. So I would divide both of these by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. 5 and 3 cannot be cross canceled, however, so I'll go ahead and multiply now. And I see that it's a negative times a positive, so my answer is going to be a negative answer. 5 times 1 is 5. And 2 times 3 is 6. My final answer here is negative 5/6. I'll put that up by the answer box. And that is how you would multiply and divide positive and negative fractions. You have 10 problems to work out independently. However, if the examples that I did here for you in this video, if that was too quick or you need some more, please be sure to come see me during office hours or reach out for help.